Okay, so welcome again to my video, and this time I'm going to share uh, the knowledge I've gathered on Kubernetes, on working with Kubernetes. This is by no means like a getting started guide for you guys. I'm making this video because I tend to forget what I've learned, and so yeah, it's a note for me as well. But I hope by doing this, I can also share what I've learned throughout you know the course. Um, so yeah, I'm sure many or all of you have heard at least about Kubernetes, or maybe have already have some experience working with containerization, at least with Docker, for example. It's Kubernetes to me. It's like the next step after Docker. So I learned about containerization first using Docker like a few years ago, and then at that time I didn't know much about Kubernetes. So I use there was a Docker Compose. It's like the first, maybe you can say it's a simple container orchestration solution. And then there is a company like Rancher. Rancher, let me just open Rancher OS. Okay. Yep, this one. Yeah, that provides the same functionality with in a more user-friendly way. Maybe it has a web UI, so you can see the containers that have been deployed, and you can even deploy from a web interface. And Rancher at that time, it also has the notion of application package. So you define that package, and you can register it on the Rancher, and then it's available on the web UI, and you can just do a point-click deployment with that. So it's pretty neat. And Kubernetes, I think it's the same and more, and it has become the de facto standard for container orchestration. So without further ado, let's just get to it. This I was working on this as part of my work on the social media monitoring. So I have this project name. Hey, wait a second. Yeah, this one, which is quite a complex system, maybe you can say it, with a few applications that work hand in hand. So you have the crawler crawling the tweets, doing search on the Twitter, and then you have another application that article inspector, and of course you have a tweet saver. So the crawler send off the tweets it obtained from the Twitter, and then tweet saver is in charge of saving it to, in this case, to CouchDB. And also, once it's been saved to the database, it's passed on to the article inspector that will go into the articles that is mentioned in the tweet, and parse the article, and extract some information from it, and store it in the CouchDB as well. Store the information about the articles. And then you have another thing called Graph Builder, which build graph out of tweet, user, articles, and many other things that we can extract. Yeah, so we have one crawler, saver, inspector, graph builder. Yeah, 4. And if we consider the web admin, it will be 5. It's just a simple web admin that that you can use to configure the crawler. So all these 5 applications uses some external technologies. The database I'm using Redis, I'm using Rabbitmq, I'm using CouchDB, I'm using Nail4j for the graph database. So, and then finally you got your 5 application here: Tweet Saver, Article Inspector, Graph Builder. So this system, for this to deploy the system, you have to deploy at least 8, right? 8 application, and it's quite some task. So first I need to get this thing right, this thing deployed correctly. So yeah, I need to deploy all of them on Kubernetes. So how do we do that easily? Well, rather easily. Luckily we have something these days. We have something called Helm chart. Before I get to the Helm chart, let me just guide you quickly through the Kubernetes objects. So when you deploy your application on Kubernetes cluster, there are a couple of things you need to deal with. Depends on your need or how complex your application is. So let me find Google Kubernetes objects. Probably this one. So what kind of objects we have on Kubernetes? Oh my god, I forgot the URL. Okay, you got the site kubernetes.io. Let me just write down what I have in mind at this moment. You got container, of course, but no. Yeah, there's no such thing as container YAML, but it's like the. Actually, Kubernetes works with something called pod. Pod is like contains or holds container or containers. Depends. There's something called like how do you call it? How do they call it? Sidecar type of deployment, something like that. Then there's deployment or stateful set. There's something called service. What else? There's something called volume, secret, config map, ingress. So let me just get through each one of them quickly. So I've already mentioned pod. So pod is like a holder for containers. So for example, just a very simple example, like you have an application that you wrote using Node.js, an Express.js application. So if you want to deploy it on Kubernetes, you have to containerize it. You have to create a Docker for that, right? In your project, you would have a Docker file where you define the image for the system where your application will run on. So you define your Docker file, and then you build with Docker build. You build an image out of it. You got Docker image, and then you use that image from in the pod. So those containers, based on your image, will when you run it, when you deploy it on Kubernetes, live within a bubble called pods, right? So why do they why don't they just call it container? Well, it's just like a higher level abstraction. In most cases, there's a one-to-one mapping between container and pod, meaning a pod uses exactly one container. But in some cases, you might want to have two pods in your or more in your containers. One is like running one container is running your application, and the other one is running like a side job. Like that's why they call it like a sidecar or something. Deployment sidecar. Yeah, that's the pattern. Yeah, you can Google it. Why, in what situation you might need to have this type of deployment. So pod enables you to define that layout. And then what is deployment? Deployment basically by deploying on Kubernetes, you declare your wish, or your wish you can call it your wish about the state maybe of your application. I mean, deployment lets you define like, hey, I want to have always 3 instances of my applications running. So in the case like you want to load balance it, or you want to have like multiple workers. So in deployment you can specify that number, and Kubernetes is in charge of making sure that it will always be fulfilled. So if one instance of the pod goes down, then Kubernetes will automatically bring up a new one to replace it. And then there's another special type of deployment called stateful set. This is normally used for services that requires like sticky ID and sticky storage for each pod. Meaning, so if pod goes down, and then it's a new instance of it is created, you want that new instance to acquire or to be associated with the resources. For example, the disk volume that was used by the pod that just died, right? So it is very important in situations like a database that has master slave architecture, like for example CouchDB, any database basically. So you want to deploy it as a stateful set instead of just a plain deployment. Service. If you want to make your application accessible by other application in the cluster, you want to advertise it as service. So that means, for example, you got your pod, you got your deployment, and then you got your service associated with that deployment. And let's suppose you name that service like my web surface XYZ. So it automatically becomes like a host name in the cluster. So from other container you can reach that service by doing curl, for example, this way. Yeah, something like that. So that's what service is for. Volume, yeah, if you don't specify volume, the pod will, the deployment will create a volume for you. But it will be ephemeral. Is that the word? Yeah, meaning when the pod goes down, well, the volume will go down with it. So you lose all the data that was that has been collected or created by that pod, and obviously you don't want that in the case of database, right? So you need to create an external volume, and then you bind that volume to that deployment. Secret, configuration like password to some services or keys and stuff like that. You want to usually we use that to store those values, so that those values can later be pulled or exported as environment variables from the containers. But you don't want that value to be exposed in any way, either in the web, in the admin UI of Kubernetes or things like that. So you keep it as a secret. You define secret, so the values are encoded. Config map, basically it's the same as well, maybe I should have written config map before secret. Yeah, they're the same. The only difference is that it's not encrypted. Now finally, ingress. Ingress is how would I call it? If you have worked with Nginx, so basically it's like a reverse proxy. It basically it makes your service accessible from outside of a cluster. So you got your service, and then you usually, for example, your web front end, you would need to create an ingress for it, because you want your user to be able to access it. So you have your service, and then you create an ingress for that, and then you bind them. And in the ingress, you define things like path or subpath, depends on what types of ingress you're using. There are several types of ingress available in the market. There's Nginx, there's Traffic, Ambassador. I've heard of that, etc. And if you're using a Google Cloud platform, Google Kubernetes Engine, they also have their own default ingress. So you have to deal with so many things for your deployment, and usually, and this is where Helm comes in, because usually to get to this point, you would have to deploy it one by one from here, like so. You got a tool called kubectl. This is a client utility to communicate with a Kubernetes server. So you got your deployment YAML, for example. So you create YAML for each one of them. YAML where you state the configuration for each one of them. Apply and F my deployment YAML, and you go into the web UI and check if it's been deployed, and then you go with the next step, deploying the service. Or even before you can get to my deployment, you have to deploy the volume first, secret, config map, etc. Things that will be needed by your container and service, and then finally you got to deploy your ingress, right? So Helm basically puts them together as a package, and in the Helm parlance, you call it as a chart. It's just package, basically. Yeah. So with Helm, you just deploy it with one line of command, like helm install my chart dot YAML, and then you would have of course you would have to create your chart project. That's this one, and then where you have all the your file here, my surface, etc. And you go to my chart, and then you do your helm install, and all with all the flags. So yeah, so it really you know, it cuts your work, it reduce errors in deployment, because deployment will always be done in the same way, in the same order, the correct order. And most importantly, in my opinion, yeah, you can version control it. So I mean, your chart can you know, can change or evolve over time, and you can keep track of it. What else? So that's why they call it package manager for Kubernetes. This one, the package manager for Kubernetes. This is a very, very neat tool. I love using it. And so that's the basic. Now let's get this thing installed on our computer, right? You want to have a Kubernetes cluster locally for the development, because if you plan to deploy it, you got several options. You have Google Kubernetes Engine, oh why there, Kubernetes Engine. You got Azure, Kubernetes Service. It allows you to get your cluster, and it also provides like some like essentials things, like manage application like Redis, SQL database, so you don't have to deploy your own chart. I think AWS also has Kubernetes. Manage Kubernetes service. Yeah, those are the three big names, right? But for development, you want to have it in your workstation. I'm using Ubuntu. Well, for that reason. Well, because before then there was this thing called MiniCube, right? So with this MiniCube, you got your cluster, but then I found something which is even easier to set up. It's MicroK8s, and it comes from Canonical. So I decided to, okay, I'll just switch to Ubuntu to make my life easier. But you don't have to use Ubuntu in order to be able to run this thing. As long as you have a snapd, you can have it. I've checked that in Manjaro Linux, you can install snapd, yeah. But I just want to have it easy. I use Ubuntu. So how do you install MicroK8s? I think, yeah, the short answer is just do snaps. Sudo snap install MicroK8s. But there are a couple of things that you need to do after that. So I've compiled some notes for that. New window. So I got a separate project for this ops thing. DevOps thing. So my application is in a project named Glass Platova backend, and the charge is in a Glass Platova backend ops. So these are some of the notes I've compiled, and I'm going to share in this video. So first, install kubectl and Helm. Okay, I've mentioned Helm. I haven't mentioned kubectl. Actually, you can just go fine without installing kubectl, because when you install MicroK8s, it comes with several tools, including Helm. You don't even need to install Helm. It comes in a package with MicroK8s. So if you type this, okay, you got Helm, you got kubectl. Where is it? Okay, this one. So you might want to skip it if you just started, but at some point you will need to. Probably depends on the way how your organization is set up, because in my case, every developer should do the deployment by himself, to the test environment, to the staging environment, except for production. And for production, we don't use this thing. It's like it's gonna be like it follows different route and more controlled. So if you're in that organization where you need to deploy to other cluster other than your local MicroK8s, so you will need to have this kubectl apart from the one that is provided by MicroK8s. I don't know how to pronounce it. And then you configure your kubectl to connect to MicroK8s. So when you install or when you connect to a cluster, or before you can connect to a cluster, you need to register that cluster in a kube config. So kubectl will read the kube config to find out what is the current cluster that I need that we're working with. So that configuration is stored in here. Bam. Well, I only have one in this file, so you can have several of them, and then yeah, it says that the current context is MicroK8s. You can check what is your current context. With this comment, it tells you. So yeah, in the project, when you do deployment to those environments, you need to be careful with that. Always check what is your current context. You don't want to wipe out the one in staging with the one that you're currently developing just because you forgot to switch the context, right? Okay, back. So that's how you connect. So this way, I've already configured my kubectl, of course, as you can see here. It will connect to the MicroK8s context. And MicroK8s context, it's this one. So this is the URL of the Kubernetes server of MicroK8s. Helm as well. Helm will also use this configuration, so when you execute the Helm command, it knows it has to communicate to this Kubernetes server. So these are, let me just open some of them. Blah. I forgot which one is the best. I think this one was one of the more complete article on it. So let's just suppose you've done that. You got your MicroK8s installed. You also need to make sure that some plugins are enabled. Status. So in my case, I have on add-ons instead. Yeah, add-ons. In my case, I only have the essential add-ons. I got the Helm version 3. I'm not sure what's yeah, it's version 2. I'm using version 3. I would say you will always need this 7. And this one is just more like logging tool, API gateway and ingress. I mentioned there's an ambassador. Oh, it even comes with a Kubeflow. That's cool. So make sure you have this 7 add-ons at least. You do that by MicroK8s, enable, and the name of the add-on, right? And then you follow the tutorial to get the dashboard configured, so you can enter. So there's an article or README on how to configure a service account such that as an admin, such that you get an admin access to the Kubernetes cluster from the dashboard. Also, I forgot to mention dashboard. So there's this thing called Kubernetes Dashboard. It's like a very like a basic web UI, but very functional, at least for my uses. And it's pretty similar to the Google Kubernetes Engine interface. Of course, it's coming from Google. Yeah, there's this dashboard which allows you to see visually your deployments. I've got it running already, so I need to get into it. So it's running on this port. Bam. And you need to enter with a token. This token, you need the token, the service account token. So I've already saved the script for that. Yeah, you need to get the token for this admin user and then use that to enter the dashboard. Wow. Boom. My dog is having a dream. Bam. Now you're in. You're as an admin. You see, I've got some couple of things deployed, but I set the replication to 0. This is a way to not running it without taking it out from the cluster. So next time I need it, I just change the replication. Where is it? Replication. There's something here where you can specify the number of pods that you want. Yeah, I have them 0, so they're not running actually, not running anything, any container. So let's just focus on what we're going to deploy. So we are going to deploy Redis, CouchDB, Neo4j, and Rabbitmq. Okay. Now, as I mentioned, you need to create lots of things, and it can take some time to write them. But luckily, there's some people that have done it. So let's just leverage their work. For example, things like Redis, it's available in Bitnami chart. Probably you can find it in somewhere else, but this is the first thing that came out from my Google search. Wow, it has lots of charts here. Okay, let's tell who wrote Helm? I suspect it's Bitnami. Helm Wikipedia Bitnami. I don't know this story. Oh, blah. Oh, it starts out as well. Anyway, I don't know why Bitnami maintains a lot of these charts. Anyway, find Redis. So there are two options here: Redis cluster. I think I've read the difference between them, but I only need this thing for local. Probably for production, you would need to consider the Redis cluster function version, but for development, let's just go with the simpler one. Yep. So that's easy. So if you just want to deploy a Redis like properly, I can safely assume it's been configured properly. Then you only need to execute this line. You don't even write a single file for that. All right. But if you're curious or you want to be sure about what you're deploying, you can, of course, get into the source code and see for yourself. So it has, yeah, it's okay. This one deploys in a master slave mode. It's not in a standalone mode, which is good because you get it from the start, that configuration. Stateful. So it's not using the plain deployment, it's using stateful set. So it has two stateful set. One is for the master and one is for the slave. Let's see the master stateful set. You see how many lines of code is here? 500. That's just for one file. So yeah, it takes a lot of work. So thanks God there's there's this thing chart available. So anyway, how do I use this here? Redis. Bam, 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 bam. Okay, of course. Then you would want to customize or configure it with your own set of values. Yeah, so you can specify your values here. Redis values def, for example. You can. How do I know about what things I can put in this YAML? Well, you need to look into the source code, because sometimes you go to the README, right? But then okay, I'm not sure. So to be 100% sure, you get into the source code, you see the values.yaml, what you have in there, and okay, thanks to this file, you can tell that wait a second, this one, all the values you put here will go to the Redis conf. Where did I read about it? Anyway, so that's how it works. you look for the charts if it's available in Bitnami, for example. If yes, then go to the GitHub repository to see, just to check how it is coded. And then learn the README to find out how to customize it. Usually you would want to customize the password, username, things like that. Yeah, and then if you're unsure, just get into the file, the source code. So you got the Redis. Now let's deploy it. How do we deploy it? Wait a second. Before we do the deployment, let me just share how I usually do it. Or things like this that you might need to have different YAML for each environment. Like test environment, you would have test YAML, staging YAML, right? And probably for the staging you will have a more secure password like this, and you don't want to have these files in the source code control, right? So that's why I usually have things like name example. Well, it should be like your password, just some placeholder, right? Use password, things like that. This one goes to the Git. This one should be ignored. Dev, staging, test should be ignored. And this template, well, this is just a copy of what we have here. Just use it for future references. So that's why I have this Git. Wait a second. Ding, ding, ding. Yeah, should. So you should have this thing. Something like this. That's just how we do this around here. Probably you have or prefer a different approach for it, but the point is you don't store password in your Git. Right, okay, you got the dev. So we are now in dev. Let's go back to our Kubernetes dashboard. You see, we have nothing at this moment. No stateful sets, no pods for Redis running, no ingresses. Well, Redis, like it is normally things like database, then you don't want to make them public, so you don't create ingress for that. But service, yes, you do, because you want to access that database from your application, right? There's no secrets for Redis. So those objects that I just mentioned, they all will be created when you deploy the chart. There's no persistent volume mounted or used by, because there's no pod. So yeah, it's clean. So let's just deploy it. Boom. So install, and this would be the name of your deployment or your stateful set. This is the chart, and this is, you can specify which version of the chart you want to use, and this is the values. And how does Helm knows where to pull the chart from? Well, repositories, you need to configure your Helm repositories. Bitnami add Helm repository. Okay, there you are. Yep, just follow this 3 line and it's available. Boom. Okay. Now let's go back to our Kubernetes. Boom, 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 boom. As you can see, a secret was created. This one. Well, in Google Kubernetes Engine, you don't even have this things to reveal the value, unencrypted value of your secret. But here in Kubernetes Dashboard, because I think it is just for development, you can see that. You got the secret. You got the persistent volume claims. This one. Yeah, persistent volume claim is like it's part of the so-called dynamic volume provisioning. So when you in your deployment or in your stateful set, you can specify, hey, I want to have this persistent volume created when this thing is deployed. So you can also go through like a manual route. So you have to create the volume first, and then you make you do the deployment. But yeah, it's just easier using dynamic volume provisioning. So this you state that by making this claim. So how do you state that claim? Well, it's in the charts, in the templates. Claim. Oh, there's no. Probably it's inside the stateful set itself. Look for the word claim. Yep. Yeah, because stateful.yaml has a key named persistent volume claim, so you don't have to create a separate file for that. The claim name, blah blah blah. And normally you have to specify the storage class, but if you don't specify that, the default one in your Kubernetes cluster will be used. In the case of MicroK8s, the default storage class is this one. Yeah, so it's just mapped to a local folder, on your machine. This one obviously is not suitable for multi-nodes deployment. So currently our Kubernetes server is only running on one single node, that is your machine. But so that's why this one will work. But if you add more nodes to it, then yeah, if you keep using this, then I think you'll run into trouble. So what other storage classes that we have? Well, there are many. You can even create your own storage class. I think Kubernetes comes with these storage classes by default, I guess. Let me see. For example, AWS. Yeah, it comes with it. I'm wondering is it supported in Azure, for example? You know, knowing that they compete, probably they will block. I don't know. Well, it's just unethical. Let me just check. Google Kubernetes Engine storage class. So let's say you have your pods running on Google Kubernetes Engine, but for some reason your storage is in Amazon cloud. So I was wondering if you can do that easily. Whoop. Yep, I think, yeah, it's official. It's supported. Pre-installed. Cool. Yeah, so you got this. But if you want to have your own Kubernetes in your premise, you have mainframe or you have a network of machines, you probably want to have an NFS, right? Let's say NFS storage is there, and you see in this list it's not supported. It doesn't come with the Kubernetes. Where is it? NFS now. Bam. So you have to rely on third party. NFS storage class Kubernetes. Boom, boom, boom. Oh. Okay, this one. So what does the article say? Yeah, so you just you just follow this. So there are extra work for that. Anyway, let's go back. So to our deployment, you got the storage class. So you have a dynamic volume provisioning by volume claim. So you see there is a volume claim made by this Redis. So Kubernetes follow through and it creates the persistent volume to fulfill that claim. Here you ask for 8 gigabytes, and this volume is mounted to a specific path in the container. You can see it here. Boom. Let's look for word mount. Where is it? Stateful set. Oh, sorry. It's in the pod. Where is it? Nope. Con pod. Stateful set pod. There's got to be some mount instruction somewhere. Let me just check. I understand why. Oh, there you are. Looks like the search is not working on this UI. Copy it. Let me just copy this. Mount, volume mount, data. There you go. There's data. Person volume. Name, claim. Name. Wait a second. How do I link this with? Yeah. I suppose it is. Sorry. Volumes. There's got to be volume somewhere. Volumes. There you go. Aha. Yeah. So, you specify in your YAML. You specify the name of the volume. It's internal to this YAML, but you have to also have to specify the name of the claim. So that's how it gets linked, because you got the claim here with that name, and then you don't have to worry about the actual name of the volume, because somehow from the claim it can be traced to the volume, and then it is known, this volume, it is known as Redis data, and then you mount that Redis data volume to a directory name data in your container. So that's how it works. Okay, so you got Redis. How do you verify if your Redis is actually working? First, you need to check here. If it's green, okay, so supposedly it's running, but you're not sure. So one way to check that is trying to get into the Redis CLI, right? The thing is, this Redis is not accessible from outside of the clusters. So you need to do port forwarding. This is the command for port forwarding. Paste. So this one is the name of the service, as you can see here. This one, it advertises on this port, so you know. So you put this is the internal port, and this is the port that you want to have on your machine. So let's just make it different. 80. Boom. Okay, so now you can access it using OSI, but you have to specify port instead of the default one. You have to specify -p and specify the password. The value that you specify here. Boom. Yep. So yeah, at least you can do this basic operation, get, set, and get. So it's working. Next, you got Redis. You got. I'll just go through it quickly because it's the same. This Rabbitmq. What do I have in the values.yaml? Okay. So it's not finished yet deploying. Let's check its status. What does it say? You can see the logs. Okay, it's great. It's starting up the container. It says it's green now, so I suppose the pot is, well, yeah, you need to check, make sure all of them are green. When you see it's green here, it's, hey, what is going on here? Oh no, black, what? Target node is unreachable. What is going on here? Secrets, deployment, faithful set, pods. I don't know. It's like just in the an error in the middle of it. You just, well, it's running now. So let's check. Doing the same thing like the port forward. Oh yeah, and you need to do 2 port forward here, because this one is for connecting from your code, doing the Rabbitmq operation, but this one is for the web UI of Rabbitmq. So let's just open this one. Boom. What's the port number? Yeah, it's useful for during the development. You can check your queues and stuff. Okay, I suppose it's running. Next, CouchDB. Use the provided blah 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 to generate CouchDB password hash. Yeah. So I googled up for that, because the password is stored in password. The password of CouchDB is stored in a file named password.ini. But you can omit this, and the CouchDB will be in charge of creating the hash and store it in the password ini. But the problem is, if you have, like in the cluster environment, you have multiple instances of CouchDB, you want to have use the same salt, right, for hashing. So that's why you prefer to specify your own hash in this format, hash of this password. So for that, you use this tool, this Python script. Just execute that and type in your password like this one, and then you get this string, and just copy paste this string to this file. Okay, there you go. Okay, let's see how it progresses. Where is it? Where is my... I think, oh, this one. Okay, it's still starting. One pod has unbound immediate person. Okay, you made your claim, but it takes a little time to create the volume itself, so that's why you're getting that error in the meantime. But yeah, it's done. It's finished. So yeah, the same thing. Check if it's running. There's CouchDB has a web UI on this port. Actually, it's also accessible on this port, because CouchDB is a very REST friendly, so you manipulate the database using REST call. Boom. Oh yeah, on the first time deployment, you need to execute this command. This is just to finish the cluster, just sending off this command through its REST API. But the next time you don't have to do that, because the configuration is already stored in the volume. So okay, port forwarding done. Let's get into it. 95984. Yeah. Oh, /_utils. There you go. Yep, it's running. Next, the final one. Neo4j. Neo4j. Nice. Oh, this one Neo4j, I couldn't find it in the Bitnami charts, so I googled it and found it here. Neo4j Helm chart. Blip blip blip. This one. Yeah, I think I spent quite some time on getting this right, because what was that? It didn't run on the first try. I forgot what was the problem. Sorry, frankly I forgot. But yeah, so just follow through this URL. Follow through this instruction, and this targzip, it contains the charts actually. So you can also, other than providing the chart in the repository, you can also distribute it as a zip file like this one. So let's just open that just to confirm. What is the like this? I don't know. Sorry, I don't remember the command for curl, but you got it here too, right? Right, you got the same thing, templates. Yep. If I run it, oh yeah, I've already run it. So let's go back to the what is going on here. Oh, the same thing, guys. Takes a little time. It's created, so it should be green by now. It takes more time. Passions. Okay, it started, so go back here. What is going on here? It's still red. Oh, it's green now. You need to refresh. Next, so yeah, let's just confirm it. Neo4j has a web UI as well, in running on 7474. But you also need to port forward this other port, 7687, because it has a wider protocol called Bolt. So you're gonna need that if you want to talk to Neo4j from your code. So let's just port forward both of them. let's get into the web UI. You need to change this because of the course thing. Yes. Oh, no, not for the course thing. I think it's for the because this name is not known in my machine. It's only recognized inside the cluster. This host name. So for example, if you get into one of the container inside the cluster, you can actually ping this. Let's say you're in the CouchDB container and you want to talk to Neo4j from there. You can return. What? Oh, ping not available. I'll show you later when we're in another container, like the testbed. The testbed does have a ping. Okay, let's just skip it for now. Go back here. 127. Yep, you're connected. Okay, finally. Now for the interesting part. Your testbed application. So I created a simple application. So just to confirm that I can talk to those 4 services from my Node.js code. So I create this thing, testbed. It is just an Express.js web or REST API. This thing that has an endpoint for verify Redis, verify Rabbitmq, verify CouchDB, verify, and inside of each one of those verify endpoint, I do simple operations like this. You just connect to Neo4j and write something, and that's it. The CouchDB as well, Redis as well. I just set a value of a key, and Rabbitmq as well. Just send a message to the queue, and you can check that if it's actually in the queue by going into the Rabbitmq web interface, right? So this one is your own, and this one, and here you're on your own. So there's no Bitnami that you can rely on. So you have to create your own chart. Oh, why? Okay, you have to create your own chart. In this case, I can use a simple deployment instead of stateful set because it's a REST API. It's stateless. Yep, this is 65 lines of code. This is the template. So what the Helm does is read the template. This is a Golang template actually. Read the template, read the values, and it also has something called helpers. So yeah, in combination of those two things, it will generate the final YAML to be deployed to the Kubernetes. So that's basically what Helm does. Deployment, secrets. What do I have in the secrets? Okay, Rabbitmq user. Some people prefer to have things like this, like username in the config map, but I would prefer to have both password and user in the secrets. Service, of course, and finally, in this case, we do need ingress because you want to access this this thing from your computer. using hostname. I've already had my DNS mask configured on my Linux. It's like a simple DNS service. So I have whatever rack.info will be routed to my local machine, and this request will fall to the Kubernetes ingress. So in this case, I can open this after I deploy, of course, .raka.info, and then it will reach this Glassdoor testbed. You got the ingress. So and my code itself, well, normally your code is separate from your ops. These are ops code, right? This is for the DevOps. You have a separate folder for your app, separate Git, but just for this case, I have it under the my ops project. I got it up. So you need to define your own Docker image. So you write your Docker file. You want to have it based on this image. Add a couple new things you might need. Run npm install, and there you got your image. So what is the step for the deployment of your own application? First, you need to build your own image. So you go here, you build it, blah blah, build. So it will build starting from this folder, and you will tag it this way. Bam. And then you push it to your local registry. Okay, this Docker registry in a real project, well, not real project, I mean for the staging, tests, or production, of course, you want to pull from remote Docker repository, right? I think GitHub it provides a Docker repository for for the subscribers. You can also register it in a Docker Hub. The thing is, first, during development, I don't want to wait for uploading of the image, which can take quite some time. And also Docker Hub, in the case Docker Hub, there's only you can only have one image accessible from outside. The other one should be kept private. So yeah, in this case of Glasplatova, in this case I only need one image, so it's fine. But in some other situation, for one single system you need multiple images, so I cannot use CouchDB for that. But the main reason is you want to make it fast during development, so you run your own Docker registry. So how do you get this Docker registry running? Well, MicroK8s comes with a Docker registry. That's why I enable this add-on. So let's just push it now. Okay, the build is done. Now push it. Okay, now it's available, so you can use it from your deployment. Image. Okay, image. So this is how you specify where to pull that image from. It's a template, image repository, values, image tag, chart out version. You got in the values dev, image here. Boom. Okay. In the case of, let's say, in the case of Docker Hub, for example, you need to specify other. Oh, this one you can. Well, I keep it around just in case then I can switch to Docker Hub. I can. It's already there. So in the case of Docker, you need to provide your credentials. So first, you need to have that credential stored as secret in your cluster. I already have that. Where is it? Yeah, I already have that. Okay, you got an image post secret. We don't use this for this local repository. So I always use always because I've run into some problem when using other values because of the caching and things like that. So I prefer use always. Less efficient maybe, but it's more safe. Yeah. So you got your image in the registry. Now you can proceed with the deployment. That's one. Values. You can specify several locations to pull the values from. In this case, I got the values like unencrypted values stored here, and sensitive values stored in the secrets.yum, in the YAML inside the secrets. Probably you don't need to do that. You can keep them all in one YAML file. Ingress enabled. So in this case, ingress enabled. I'm using it in this template. So if ingress enabled, so this YAML will be generated, and Helm will be in charge of, applying it in the cluster. Copy. Boom. Check your deployments. Okay, it's still in progress. I'm requesting how many instances of testbed I'm requesting. Replica count. Values. Oh yeah, in my case I just development, you don't need to have 3 of them. I do the same for other for the servers, like here in the case of CouchDB, for example. I don't need the master slave during development. I just need the master. So that's why I specify cluster size equals to 1. The same with Redis. Where do I specify cluster size? Oh yeah, I disable the clustering. So I'm running one single Redis node. Neo4j as well. Standalone true. Rabbitmq as well. Oh, yeah, it's the reverse, I guess. You need to specify a value in order to enable the clustering. Like, I'm not sure. Yeah. Clustering, blah blah blah, rebalance form. Oh yeah, this one. The default value of the replica is 1, so I don't need to change that. Okay, let's go back here. Deployment. Boom, it's green now. Oh, one final thing. Here I specify something called Liveness probe and Readiness probe. Well, they are almost the same with different stage where they're used, but let's focus on the Liveness probe. So it helps you to let's say automatically recover from unknown problem, maybe. Let's say for some reason your application crash or get stuck, but still running. I mean, the process, the Node.js process, is not it's not bad. If you don't provide Liveness probe, Kubernetes will not restart that container because, yeah, it's running. The process is running, but actually your application is stuck. It's dead, right? It's frozen. So Liveness probe helps in that situation because you provide, like, there are a couple of ways to check for liveness. One of them is through HTTP GET. So Kubernetes will issue a request to this container, to the service, every 30 seconds. So if it responds with HTTP 200, can tell, oh, okay, it's working. But it's not, then Kubernetes will proceed with shutting down that container and starting up a new one, fresh. So that's what the probe is for. So of course you need to write your own probe here. So that's why I have it here. Readiness. Yeah, I use the same endpoint for liveness and readiness, this thing. So in this case, I just check if Redis is connected, if this code is connected to Redis. That's all. Okay, it's up. So let's just let's just verify it. Raka info, verify, Redis. Boom. Okay, I'm using HTTPS as well. This is cool. Because you got it right from the start. And let's get into the ingress. Blah 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 blah. Spec TLS. Values ingress TLS. Secret names. Let's check here. TLS secrets. Yeah, for each certificate I store it in the secrets, I guess. Testbed. Where do I store it? Range for TLS. Let me check that, because I have this folder called TLS cert. This is like my self-signed certificate, as you can check here. Oh, a fake certificate created by Kubernetes. But how do I use this? I forgot. I think I've missed some step here. It looks like it's not using this TLS cert. Instead, it's using an auto-generated certificate, and of course, it's only suitable for the development. In production, you would want to deploy your own certificate. So, yeah, you want to have this, something like this. Glass Platova testbed info, Glass Platova testbed dash raka dash info dash tls, because that's the pattern I'm using here. Full name, values ingress tls, values ingress tls. Oh, I don't specify ingress. Yeah, this one, roles TLSO. Yeah, I want to have this, so I forgot to. Yeah, this one has to be uploaded manually. I have it in my other project. Is it here? Oh, there you go. Blah blah blah. Okay. I just think I need to copy these notes to. Glass Platova testbed raka info tls. Glass Platova testbed raka info tls. Hey, wait. Boom. Blah blah blah. Okay, so I need to undeploy my Glass Platova testbed. With this command, uninstall. You can also check active deployment. This command. Well, not active deployment, the one that you deployed. Okay, it's yeah, it's uninstalled, so you don't see it here. And the ingress has also been deleted. Where is it? Ingresses, yeah. So let's follow through this series of instruction. Host, this one. Let's put this one. Yep. Boom. Yep, and you can check it here. Secrets. This one. Now, when you deploy it, you'll see that it is using your own certificate now. Okay, it takes a little more time because of the Readiness probe. The Readiness probe introduced some delay to the green state because of this. So it adds like 10 seconds of delay, I guess. 10 or 30 seconds. Yeah, one of them. Now it's green. Okay, now let's go back to our refresh. Now if you check here the certificate, why certificate? You see, it's no longer the fake certificate created by Kubernetes. It's our own certificate. Okay. There's also other options. Usually this is very useful because it gives you issue certificate to your services, and we use that a lot in production. See, for our usually we use it for our REST API and stuff. Yeah, but you need to do a few things. You need to have first you need to I don't use it here because it requires a public DNS, because it for the proof of claim first you need to have a container running in your cluster. This is called let's encrypt Kubernetes. How do you call it? Like Kubernetes certificate manager, something like that. And then this container will need to talk to your DNS to write an entry, a record on that, like a text record, something which contains the keys provided by the Let's Encrypt. So that's how you prove that you're actually the owner of that host name. Yeah, so that's how it works. So I'm not using it here because I don't have a public DNS. Well, I have it in GoDaddy, but I'm too lazy to configure it now. Okay, so there's you got this option using Let's Encrypt, which I would highly recommend. Okay, back. It's certificate. Yeah, Google Chrome can be a little bit picky with that kind of certificate. That's why, and it can break some functionality sometimes, this blocking. So that's why sometimes I use for development I use Firefox. Oh, the same. Oh. Okay, you got the here. Let's just okay, fine. I know what the risk is. Okay, verify Redis. Its status okay. Verify Rabbitmq. Okay, let's check it. Rabbitmq. Where's it? There. I just sent a message to the queue. Let's see if it's there. There. Queue. Get messages. 5. Okay, there you go. There's one message in the queue. Verify CouchDB. What? Oh, what is that? Oh, I forgot to fix my code. Where's the testbed? In the Docker app index. CouchDB. Verify couch. Blah blah. If it doesn't exist, then simply insert. Otherwise, it's a why. There's no okay. Now let's get into a little troubleshooting. Glass plateau testbed. Let's see. Logs. What was the error? Oh, it says database does not exist, right? So that's how you do. You check issues on your container. You go into, the admin UI. Go to the pod and click this log thing. Yeah, but for production or staging or test, you want to how how do you call it, like collect them together in one place. So that's why you want to use things like Datadog or something similar. MicroK8 status. It comes with something like that. Yep, you might want to enable the Prometheus. Okay, a database that's not like, oh yeah, that's normal. So I forgot to create this database. So let's create it in the CouchDB. CouchDB. What's the name of the database? Forgot. What's the name of the database? Glass, of course, glass part of a testbed. And now it should work. Pew. Okay, a record has been created in this database. There you go. Okay, verify. Next, verify Neo4j. Okay, status okay. Let's check it in the Neo4j UI. Is it still on? What is the port forward? Is it still? Refresh. Oh yeah, I need the other one. 74. Oh man. There, you got a node here created. Cool. So, yep, I think that's all. Oh, the final thing. You've seen that I jumbled through tabs, adding port forward here, port forward there. And so I collect them in one single script. Maybe useful. This tip. This one. All the port I need in development. So yeah, this is also useful during the development, because okay, you have your Redis, Rabbitmq, CouchDB, and Neo4j running on your local Kubernetes, but you don't want to deploy your application just in order to be able to test it. But still you want to connect to your Redis, right? So you can do that by doing this port forward. Let's just do it at once. Let me just close the tabs. It's getting confusing. Okay, so you're working here, right? This is your project. So you do proxy service. So you got all the port forwarding. And here you work on your code. You make some changes, and then you test it by running locally without having to deploy it. Okay. Oh yeah, right. One more thing. It uses environment variables, right? Here, and you haven't defined that environment variable. You need to define that. So that's why I have this file .env. For the local development, I set everything to home address, and then I export them using this command. Boom. Now you can run your code. Okay. Okay, it's running. Verify. Okay, cool. So that's how it works. The last thing. Oh, you might be wondering, how does this environment variable get into the container? So if you go into the testbed container, you type env here, you see the same value as you get here. Let's say Rabbitmq host. Your glass platova Rabbitmq. How do we register those environment variables, right? The keys here in the deployment.yaml environment. Oh yeah, I got this helper that will testbed and include. Okay, let's just get into this template, this helper. It will name value dot secret and it will read from values image. Yeah, here it will read this thing env, right, and generate this section of YAML, and then to be embedded here. Env something. Env is that's how you specify environment variables for your container in the Kubernetes deployment YAML. So just connecting the dots here from the values. You put it here, and then you got your helper that will read those values, and then those values will be then just in line here, right? Okay, I think it's been a very long video. I hope it's useful for you, the way it is useful for me and my team. So that's all. See you later. Bye.